Welcome to the Easy CG channel again. So today I'm going to show you how to give a various type of thickness to a cable or a tube, whatever you guys want to do it in your project. Like if we see in the real life references where you can see that all the cables are not in the same thickness. Some are thicker than other. Like there are various type of thickness we can see here also, in this also. So today we have to achieve this one, and it's very easy. I'm gonna show you two ways, one without vex and one with vex. So let's see how we can do this thing in our Houdini. So I already have this curves, like hanging type of curves. You can see I already have. So now for making this as a geometry, let's take a polyware for now, and if I connect it like this, sorry, my bad, like this, and if I go here, where is the division called 32 for smooth? Yes. Now here you can see that all the tubes are in same thickness. So how to differ it? We don't have any option of the radius here, like various radius here. Here is a global radius is there, where if you increase it, then it will globally increasing for every curves. So let's see how we can do it. So first we have to take one connectivity node. So let's take a connectivity node and I will place it here. Yes. And if I go here, I have to change it to primitive, and rest will be whatever is there, it will be like that only. Okay. Now I will take another one, attribute randomize. So if I take one attribute randomize, if I connect it here, instead of giving the CD, I have to give a p scale name here. This is the attribute which will work. This is the main attribute for the differing the scale, and I have to give this one as a 1, because for the scale only one dimension we need, and we have to change it to primitive, this one also. So here we are getting one minimum scale and maximum scale. So let's give like 0.1 for now. And now as if I click this one, then again we can't see any scale difference in it. Why? Because these two nodes are in point, are in primitive, and if I stay in the primitive level, then it will be globally doing the scale thing here. So we need to change this primitive to point. So for that we need a attribute promote. We have to take one attribute promote. We have to click in this one, and in attribute promote we have to do, like if I click this one, our name will be, that attribute is p scale, and from primitive to point. Yes, that is done. Now if I go here, and now if I go and check it, something is there, I need to check. Everything is working. Oh yes, sorry, my bad. So here in where radius we have to give that p scale information, that p scale attribute in this polyware. So how we can do it? Here in the where radius we have this constant option, we have to click on it and we have to give an attribute, and here by default that p scale is there. So now you can see that we have a difference in the radius of the wire. Now some are like less thicker and some are thicker. So by this way we can use, like we can give various thickness in the tubes. So if I go here in the P scale and if I increase it, look, it's increasing. Now here also we can give it, like we can differ the scale of thickness of the scale. So this is the way, like without using vex. Now let's see how we can do the vex. Only nothing will be changed, only we are adding some few lines of code and it will be happening. So let's take an attribute triangle and let's have it here, change it this one, make it, again we have to change it to primitive first, then let's connect this promote to here and we are disabling this one for now. So let's see like this. Okay, now in this one we have to write something. So first let me write the code, then I will explain one by one why we are writing those codes. So first I will write int, we will take one integer value and give a name, anything you want. I will give like class cls and it's equal to I@class. So what this is doing, it's calling the class attribute, what we that we are getting from this connectivity node, this class attribute. It's actually counting how many curves are there. So if I go and click on this one and if I go to the geometry attribute, a geometry spreadsheet, and if I go to the primitive level, you can see like it's counting how many is there. So we have a 5, so the highest value is 4. That means it's only 0, 1, 2, 3, 4. So that value we need. So for that value, for calling that class attribute value, we need I, that is integer value @class, and we are storing that value into our internal integer value into the class. Then the next I want some seed values to differ. So let's take a float value and call it as a s for whatever you want, equal to, we want a slider. For slider we need chf, and let me make this one a little big to see, and here we will type like seed, what the parameter name, and close and done. Now again we need a random value to give a randomization of the seed. So for that one we have to give like again float r, let's set r equal to fit function, fit01 function we need not fit01 function, we don't need this one for now. Like take a random function, rand, that is a function. Inside we will give our class value, whatever class value is there, multiplied by like some random number like 1, 2, 3, 0, whatever you want. I will give like this, then plus and our seed value, whatever seed we are giving, so equal to 10. So now we have a random seed. Now every time it will change whenever the slider we will changing. Now we have to give this random value to our p scale. So for that, let's create one p scale for now. So for creating the p scale globally, we need f, that is a float value. That's why I'm creating with f @p scale equal to. Now we will using the fit01 value. This fit01 function will keep the values like within 0 to 1. So after inside that one we have to give that random value, our r. Then again we need a slider for minimum and maximum values of that thickness. So we have to give that chf, and inside we will give like min thick. If I give like this, min thickness, and after that comma, and let's copy this one again, copy paste. Now here I will give max, then at the end I will give semi this one and done. So now if I click outside and check if there is an error, no, there is no error. That's good. Now if I click on this slider button, I will get the 3 slider which I made. First is that for seed, second is for the minimum thickness and maximum thickness, and is that. Now if I go here and click on this one, and I can't see anything. Why? Because if I go to this wrangler, I didn't give any thickness values here. So let's give like 0.1 again, and here like give 1 again. Now you can see we have a thickness variation, and we have a seed also, so you can change the seed to play with these things. So it's very easy with this wrangler also, and I will also give this code in the description so that you can use it if you don't want to like remember these things and all. And another one thing, we have a very beautiful node called sweep that is work exactly like polyware, but it's little advanced. So let's take a sweep and let's see how it will work. Like in polyware, we have to give this attribute p scale here, but in sweep it will take automatically. So just change to this round thing, and you can see it's automatically taking. Now let's change to 32 for this one. End cap if you want, just give a grid or a single polygon, whatever you want. It's also working in this one. So these are the ways you can do it for this for these tubes and all. I hope you enjoy this video. Please do the like and subscribe, and thank you.